For the apparatus, we use the metallurgy microscope. For the next step here is we switch on the laptop and then we click for this software, and then after we click that we go to the left and then we press the icon and then we click again at the right at the right icon and select any symbols that we want. For the steps 2 is we switch on the microscope. For the next step is we put the sample and place the sample under the magnificent lens. For the next step, we bring the specimen or the sample to the up for near to the microscope lens so that it will be more focused on the specimen. Be reminded, do not near to the microscope lens. For this step, we adjust the obstacle lens so that we can see the sample with the clear image, and then we can proceed our experiment. For this stage is we move the stage down a little bit for the computer to read or get the image clear at the software. To adjust the image to be more clearly see, we adjust the fine focus lens to make the image is more clearly to see. For the next step, you can adjust the magnification lens for zoom in the image on the sample surface by rotating the magnification lens. Be reminded, do not hold the magnification lens body while adjusting. Use the magnification lens holder to change the magnification lens. The final step is, after doing the whole step, continue observation on every sample that has been given in this experiment. We've used the same step, and then for this is the important one. After you using the microscope machine, we need to switch off the machine. Hi, my name is Alex Tehelson and Anthony. For today, I would like to present my observation on the microstructure of cast iron experiment. Here is the result that I draw, and then this is the image for the ductile cast iron, and this is for the gray cast iron, and then this is for the white cast iron, and the last one, this is malleable cast iron. So we move to the discussion. For this discussion is first is differentiate between steel and cast iron with reference to their carbon percentage and hardness. The most notable difference between steel and cast iron is the carbon content. Cast iron has a carbon content greater than 2%, while steel has a carbon content of less than 2%, with many steel alloy having less than 1%. That is the extra information. And then the steel is ductile and malleable, whereas the cast iron is hard and has high compressive strength. And the next one is, on the basis of microstructure, briefly explain why gray iron is brittle and weak in tension. The tip of graphite flake acts as point of stress concentration, and then gray iron graphite flake are embedded in a ferrite or pearlite matrix. So this is the answer that I guess it's correct. And then last one is the compare white and non-dual cast iron with respect to A composition, B. Microstructure, and C. Mechanical characteristic. For the white cast iron contain 1.8 until 3.6 copper, 0.5 until silicon, and 1 until 2% manganese. Main contain massive cementite, white and pearlite, and it has a high compressive strength and retain a good hardness and strength at a higher temperature. And then the range of the chemical composition for the nodular cast iron with carbonate and mixture of upper and lower bainite was as follow. They have copper 3.57 until 3.83%, silicon 2.36 until 2.87, manganese it has 0.05 until 0.09%, and then 0.0 until 0.3%, and it is completely ferrite. I displaying height there is a problem. This is displaying high ductility, elastic modulus, and mechanical strength and correction resistance. And I think that's all for me. For the conclusion is this experiment has been understood. So thank you.